Okay, so this is session 3, and just to clarify kind of why we have this up on the screen, I'm showing what we're doing today. So today we're going to build this sub VI, and we're going to explain what it's for. And essentially it's a direct replacement for this one that we've used in the first couple of sessions. This is an inbuilt Labview VI from I think it was introduced in 2008. It's quite a recent addition. Before this one came about, the one that everyone's always been able to use is this one. It's a low-level VI, and all it does is list what's in the folder. It has no level of sorting or filtering or anything else. And then they came out with this one to try and make things a little bit easier. What we want to do is take it one step further, and although this one allows you to filter depending on a pattern, we want to also make sure that we're filtering it and ordering it the correct way, and not the way that Windows wants to show you. Okay, so like I was saying here, this is a direct replacement for this, and I'm going to show you how to not only make the contents, but how you make it into a VI so that you have these little tabs, and so that you can change your picture so that these handy little sub-programs you can write on your own. Okay, so also just quickly I'll open it up. Like I showed you in the preview video, the front end is pretty basic. There's not too much in there. We have error commands in and out, file location, and then the pattern that we want to filter it with, and then the list of files. We go to the back end. It's quite clean. It's a very linear program. Nothing runs at the same time, but it's doing something complex. Here's this low-level inbuilt older VI which lists a folder contents. We're using that with our own particular pattern. We're feeding this in such a way that we can create our own numbering scheme for these files. One of the issues is that these files, as it lists them, are in the Windows format. So actually I can, maybe it's easier if I just draw on the desktop what I'm kind of talking about. Yeah, we don't need that. So, in most operating systems, the numbering schemes go from left to right. So if we write 100, and then 101, and then 102, and tell it to order this list, it would order it this way. If we put 104 and then 103, and we said reorder this, it would switch these two positions round on the bottom. Okay. If we try a different set of numbers and we do 1, 2, 3, 5, 7, 10, 12, 23, 50, and said order this, it always starts with the first digit. So it starts with 1, and then it's okay. Then it looks through the stack and says, does anything else have a 1? And it's like, okay, 10 has a 1. So okay, let's move 10, and then 10 goes. In some cases it goes before, some cases it goes after. Labview actually puts it before because its second index is 0. So it would then order it like that, but then it's like, oh, I've got 12 too. So it's like, okay, well, let me move the 12 and put it before this index too. So then so 12 would go here. Then it goes 1, and it's like, okay, now my next number is 2. Oh, I've got another 2 down here with an index on it. So then it would put it right there. So you can quite quickly see how out of order your things go if you just allow Windows or Labview to actually order them itself, because the way it knows how to number things is it goes from left to right. And for most things that's fine, as long as the program that wrote the file number is reading the file number, because it knows how it wrote it. And, a lot of times with Labview, you're actually analyzing data from different locations, different sources. So in this case, we're actually analyzing numbers that were written from a program that LR wrote, and he doesn't zero pad file names. He writes it, 1, 2, 3, etc. But if we tell it to order that, it'll order it in this manner. A lot of times in Labview, I'll show you a little sub VI that I wrote, which essentially does things called zero padding. And what it means is, for the average experiment, 5 or 6 zeros is bigger than any. You don't generally have more than, say, 100,000 files for your thing. So before it writes 1, it writes a whole bunch of zeros. And then when you write 10, for example, 10 looks like that. And then when you write 100, so you can in fact order them, and this example you tell it to do a reverse order because it goes along here. It's like, okay, all these zeros, okay, this is 1. So I keep doing all the 0 indexes, so those all go first, and then 0 indexes, then the next one is 1. So going left to right, it can always put them in the right order. So this is called zero padding the file name. I have sub VIs that write this, and you can look at it yourself too. Essentially, you make a little script. So if I show you on the block diagram what it does, basically, you have something which adds things to a string. So this is called concatenating a string, or adding things to a string. And then rather than just wiring up the I value for the next, we use I values to just increment the name. Rather than doing that, we run the I value into the bottom one. Because this is a string, we have to convert it from a string into a number first, from a number to a string. So we would essentially take this number, and then we would get a string out, but we'd do this inside a loop. Actually, I'll do it inside the loop so you can see what we do. So we would take this I value, put it into as a number, then we'd get out a string. But we'd run this string into the bottom, and then we kind of just choose, a constant. Oh, okay, let's put 6 zeros in the front of every file name, and then it'll give you 0, 0, 0, then 1, or to start off with it would be 0, and then we just need to go back into the string palette and then convert this string back into a number. So decimal string to number. So we would just wire this guy back up, and then we get a number out. So if we use this number as a file name rather than using just the I value, then we've essentially solved our numbering issue. That it now is going to number them in exactly the right order, because we have a whole bunch of zeros to start with. We're not starting with 1. This falls apart, so this does not work if you say, here we have 6 zeros. If you had 10 million files, or 10 million loops of the cycle, this wouldn't work, because now after 1 million, or when it hits 1 million, 1 becomes the first index, and not 0, and the number of characters changes. So if the number of characters changes, the numbering scheme is not going to work, because we're basing it on, we have enough numbers that we're only going to fill up this set of characters. As soon as we go bigger than this set of numbers, it doesn't work anymore. And generally, you just pick a set which you'll never hit. I mean, 100,000 files is kind of getting a little bit big. So that's a reasonable number to use. When you have control over it, let's say we're analyzing the data sets of Selene or anybody else, and what you're actually doing is rewriting the data. So you're extracting things from the data and you want to save the images. You still want to use the same kind of zero padding system, but rather than inputting an arbitrary number, what we do is we measure basically how many files there are. And then based on the string length, so let's say it says there's 300 files. We can then use a little thing that measures the string length. So it says, okay, 300, the number 300, has a string length of 3. The first characters are 3, and then there's a 0 and a 0. So it'll say 3. So then you can just feed that number straight into here. We can say, look, if we need 3 zeros because we've got 3 characters, and then it'll modify itself depending on how many files there are. If all of a sudden you're in a folder that says there's 1,000 files, it would then say, okay, I'm seeing the number 1,000, that's a character length of 4, so then I have to pad with 4 zeros. That you can actually make it modify itself, that you don't have to have a hard fixed number. We have a hard fixed number here because this is an example if you wouldn't know. If you did know, then we could modify it. And if you have questions on that, I can show you exactly how you would do it for that example whenever it pops up. But just bear in mind that numbering schemes are problematic with lots of programs. And what I'm going to show you here is if you ran the previous one on a certain data set, you'll see a difference, because before this was actually a bug. If I bring up your data set previously, if I can find a program, session 2, actually we can do it in extra. So if I load up, if I run this program, and then load in the files that you're analyzing, you're in here somewhere, right? Experiments, something for here. Oh, it's gonna freak out like crazy. Maybe we shouldn't use these ones. Let's see what this one looks like. Okay, this one's clean. Okay.
Why the rest are dirty?
So no, there's so as I'll be showing you, I've modified that set of images with other things, like some extra random files to show that they are not included in the file list. But with this one, I don't want to show that. So now it's doing what it was doing before, and it's going to load up all these files. As long as it, wow, there's a lot of files in this folder. But it's going to number them wrong, and all of your attempts on the other ones, they've been wrong. So the data would have looked noisier than it was supposed to, because it was always it was analyzing the files in the wrong order. They were more or less in the right order, but there was all these kind of breaks where it would stick in extra numbers. And the result on the data would be, you'd have something that was increasing, and then there'd be a pop down, and then it'd be like some more, and then there'd be another pop down, and then there'd be like a couple of pops down, and because of numbers that it's picking in. With this new VI that you can use, you can actually replace it in your other programs. If you replace it in, it should work as written. And you shouldn't get these little pops. It should have cleared them out and reordered them in the right way. If this thing speeds up a little bit, we'll be able to show the error. Come on. You go. There we go. So a lot of these kind of upper pops here, going down to 0 values, probably aren't there. In fact, there's probably lots of them in the sequence that, the data probably isn't this bad. It probably is a lot flatter in regions, and then of course there's going to be some spikes, but essentially having let's choose a bigger region. Like, these things probably don't exist. This is probably just an artifact of the numbering scheme always going back to a lower number, because there's so many files. Okay. We haven't stopped. I'll show you in the next data set using the new one what these look like when it's ordering them correctly. Okay, so first of all, we need to speed up. So enough about where the bug is in my program. And we'll look more at what we're going to do today. So as usual, we'll scrap all of these. and we'll make a new one. Okay, I'm going to steal your handout because I don't have mine with me. Can I borrow your handout? Oh, this one. So I know. So I don't put things in the wrong order for you. So on the bottom of the handout, there are two things. One is called the connector, and one is called the icon, and they're actually the wrong way around. The one on the left here is the icon, and that's what we're using to represent the VI. So just like all of these things have their own, icons, we have to make our own too. This was just my way of representing that the red number, which is being filtered out, and then we have 1, 10, 2, and then it's ordered to 1 through 10. So this is just a quick pictograph to say it's ordering the list and it's filtering out down. So it's just a pictogram to tell you what the VI does. And on the right is called the connector. So if you if on the front panel you right click on this thing, this little icon up here in this corner. So if you right click on it, you should have a couple of options. Edit icon, show connector are two of them. Okay, so if we go to show connector first, you should get something that looks like this. And all of these boxes are essentially places that you can connect inputs to. And that's what the front panel is. It shows you all your inputs. You can change the pattern of these terminals so that if you have an awful lot of things you need to wire in, you can do something really, really heavy like that. Or if you've got something very simple and you just want to wire in, like simple input output, you can do it simply. You don't need. But for the most part, this only changes the position of them. If we don't wire up all of these things, they're not available. They're not blank. We only actually see connections for the ones that we input. So if we quickly just, as an example, if you just right click and go to like a numeric control, let's put a numeric control on the front page. Okay, and then we click, so you hover over one of these connectors and click with your spool of wire. So left click the spool of wire over one of the boxes. Okay, it should go black. Okay, and then click somewhere on the response. So if we left click on there, okay, see that this is now changed color. It's now orange because this is a double point precision number, and this is now the input. This is now, this is essentially, going back to the thing, we now, if we made this sub VI just as is, the VI would allow you to just put a number in. It doesn't do anything with the number, it just puts it in. So quickly we'll do something on the back end and we'll get an output. So we'll do a very quick addition. So if you right click and go to your numeric palette, and then put an addition symbol on the back. Yeah? Good. And then go to the, if you left click on that one, then hold down control. Hold down control. Okay, and now drag something off it. And you'll make a new one. Okay, and then we can just wire these two things into the addition. Okay. Then right click on the plus symbol, kind of the last dot, and then go to create indicator. Okay. Right. So all this VI does is add two numbers together and give you an output. You know what? We should actually let's do something else because this is really boring. Let's square it too. So if you delete this wire, and go to your numeric palette, and we're just going to square it, because then at least we're doing something else. And then just kind of connect the wires. So here to there, and then there to there, so that we're adding two numbers together and then we're squaring them. Okay. Okay. So if we go now to this, now if we go to the front panel, let's just kind of move things around to clean them up a little bit, so it's not so disorganized. Okay, so numeric 1 is going in here. So now we'll pick another one. Let's pick this one, and let's connect it to numeric 2. Okay, and then pick one on the right hand side of the connector, and let's click it on the output. Let's just give these some names so we know what we're dealing with. So let's call this the Solomon square. Input 1. Input 2.
Of course, I don't remember how you do.
How we do it? What would you like to do?
Like to have this orange thing.
Okay, so you just so click kind of close to the. So if we, yeah, and then you can just drag it.
Yeah, but why it's not?
That's not much.
You know, like you.
Oh, sorry. So you want to
Yeah.
left click in one of those, and then left click on. There you go. And that's
Okay.
connected. Yeah.
And how you move, you know, and it's.
So click somewhere in it, left click in it, and just drag it. So do what you had. So no. So click on it. There you go. Now just left click inside this square.
Sorry.
Nice. So you just left click on the box.
Yeah.
Okay, so then the whole thing's kind
Mhm.
of glowy thingy, and then we just
Okay.
hold it and drag.
Okay, thanks.
So the question is how you move these things around. So you kind of click somewhere in it until you get this dotted line all around it, and then left click and drag, and you can just move it wherever you want it. Not. Okay, so we should all have these things laid out now. Okay, so we have a connector up here, so that's right click up here. So if you right click on this one and go to show icon. Okay, we should have changed now back to the icon. And then right click and then go to edit icon. Okay, so this is, you know, essentially Microsoft Paint. It lets us draw and do things, basically whatever we want to do. You have your categories and all the rest of it. You know, there's certain things. The ones that you really only need to worry about are the glyphs. So let's see if there's anything inbuilt that we can use. Oh, we can use this plus symbol here. So, you know, it's basically Microsoft Paint, so, you know, it's basic. You can do whatever you want. The only difference is if you click on a glyph, then you can just drag it and put it wherever you want. So we're going to put it right there. Click on text, and we're just going to put a little, whoops, let me change that glyph. Just going to put a 2 there to say it's the sum squared. So there we go.
How you remove everything and.
So because it's exactly the same as Microsoft Paint, I'll show you on the big screen.
Okay.
Because it's the same as Paint. You know, Microsoft Paint, there's basically draw a line, draw a point, you have an ink drop and a fill. So this one is a selector tool. So you take your selector tool and just draw over the top. Just draw a selection and then hit delete. Yeah,
Yeah,
you want to
delete
leave.
everything.
Yeah.
Okay.
Now you can just do your fun things. You know, it's your chance to do something creative in Labview and having a pretty picture for your VI. You don't get a chance to do very many pretty things in Labview, so.
Can we just input write some words on it without any symbol?
Yep, so if you just, so if I want to, just like I did with the 2,
Yeah.
just hit text, and I just call it this. Maybe not there, maybe so you can see it. Yeah, this is,
Square and
yeah, just click on the text symbol, the T, and then just put number 2 somewhere on the power.
Oh. Okay.
So just click somewhere and then write 2.
Okay.
Just once you highlight it, just click on the screen and then click 2. Okay, maybe not quite that high, but click further down. Click further down on the screen. There. Okay. And then if you want to put this towards the end, you just use the little selectory thing. Just say, I want to move this region, just like Microsoft Paint. Okay, and then just hit OK, and then you should see that boom, it's up here now. So both on the front and back panel, this is now how this VI is shown. Okay, we need to save this somewhere, so you go to File, Save or Save As, doesn't matter, and just put it somewhere where you know where it is. We can just call it Sum and Square. Sum and Square. We'll just drop it on the, I just dropped it on the desktop anyway. And then if your VI looks anything like mine, you can hit the little cleanup button. And then it cleans it up for you. And then hit save again just to keep it all clean. Okay?
I'm not sure. To save just these things, how you do?
Save what?
You saved in what you did before.
Just go to File, Save.
To save all these
Yep.
things? Okay.
We want to write it as a VI. Yeah. So just click on the desktop or something. Probably don't put it there. Okay. So we've got a little file somewhere now. So we can close this guy, because we want to make a new VI now, and we're going to call our sub VI. So we want to go to blank VI. So make a new one. So just close down the one that we just made. Let's make a totally new one. Okay? Go to the block diagram. Okay? Now we right click on the screen, select a VI, find the VI that you just made, and hit OK. Okay? So everyone should have this something that looks a little bit like that. Yeah? Now you can put things on the front, but because when we made this little sub VI, we said that these were control inputs and this was an indicator output, and it knows their numbers. That rather than having to actually put boxes on the front panel, we can just tell it exactly, basically use the same stuff. So if we right click, go to create control, right click, go to create control, and then right click, create indicator. And you should notice they're all named the same as what we named in the sub VI. So it's pulling the names of these things over to, because we're trying to keep them as, similar as possible. And again, we hit cleanup because it looks pretty.
It doesn't work.
Doesn't work.
It's not. Oh, but I didn't choose that. No, it's okay. It works.
You okay?
Yeah, I'm okay.
Okay. So you should have something that looks like this. And we can just type in a couple of numbers here. So 2, 2.
It's just, of course, I didn't change name here.
That's fine. You don't have to change the name. It's just.
I also have a question about
Yep.
my problem. So I got this one, but it's a little different. I haven't this box for.
You have.
I mean, I haven't this one. I have this, and I haven't this.
Oh, but that's fine. That's just that you deleted the box too. It's not big deal.
Okay.
It's just how you drew your picture. You just deleted your box around the picture too. Do you have something that looks like this?
It was free indicator, or I don't remember.
So,
It was free,
so if you delete this guy first. Okay. So hover over the VI. Okay, then right click on that. and then go to create control. Because we have to do some. We have to tell it to do something. So we need to control. An indicator is a result.
Yeah, okay. So
Okay. 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 So then just go to your front panel and stick in, a couple of numbers. Doesn't matter what. Just drop in a couple of numbers. If you use numbers that are not pretty small, you should know what to expect. So then if you have a bug, then we know that this should give us 16. Okay. So if we add those, and when you hit run, it should just tell us what this value is. At 16. It's exactly what we expect. Pick another one that we expect. 3 and 3. So that should give us 36. Okay, so it's doing it right. It's doing what we asked. I mean, this is a very simplified sub-VI because it's almost as quick to use a sub-VI as it is to actually just drop the things on the back panel. But if we had a whole complicated set of instructions within this, then it would do the same thing. It would do all of the processing and then spit out the result. We can also, are you okay with that? Yep. So right now you have to run the VI each time you want to change these numbers. Yeah. So we input something before we hit go. If we hit go, it reads those numbers in and does some work to it. But what we want to do is actually, rather than having to hit go each time, we do it in real time. We want it to actually, we want to type different numbers in and it tells us the answer. So the way that we do that, just like with the other examples, is we use a while loop while we're waiting for feedback. Okay, so if we right click, go to structures and go to while loop, and we draw a while loop over the whole thing. Okay, so now that's going to keep reading in and outputting these variables as fast as it can. So we need to put a time delay in here because it's pointless it being faster than what we can type. So if you right click and go to timing and then go to wait, we'll put a little time delay in here. Okay, and then just right click on the left side, so the milliseconds to wait. Go to create constant and just type in something. 30 is fine. That'll delay each loop 30 milliseconds. We also need to, right now if you look, there's a little broken arrow, which means I can't run. And it should say that, we need to wire a decision to this terminal. So if you click on it, it should say conditional terminal is not wired. If you hit show, it'll show you exactly where that terminal is. So we know that we have to wire this, so we need to put a stop button on here. So the easiest way to do that, just right click on here, go to buttons, hit the stop button, drop the stop button on there, and then just wire the stop button into the terminal. Okay? So the arrow should now have gone white, meaning this VI is fine to run. Okay? So if we go to our front panel and then hit run, it should stay light gray, so we've lost our checkerboard. And then we should be able to just increment these values up and down and it instantly changes. So if we just pick on one of them and then just keep incrementing it, it instantly reads out the value. Same with the other one. We essentially have now a real-time sum and square based on these inputs. And then when you're finished, you hit stop, and then it stops the loop. And that essentially is, a real-time use of a sub-VI that you wrote with just standard numeric input and outputs. The connector that we made, so right now, if you're in this block diagram, you don't have to keep opening up these as separate programs to actually see what you put inside it. If you just double click on it, it will open it up as a new window. And then just go to Window, Show Block Diagram, and then you can see what your sub-program is. And equally, we can go ahead and modify this program while we're inside the other program. So if we want to change something, okay, well, let's not do the square, let's change it to square root. Now let's right click and change this to square root. You know, so we delete this guy. Let's run a square root of this guy. Yeah. So once you've done that, just hit save and just close it out. Just close it, make it go away. And this would automatically have changed to take that new thing into account. So rather than squaring it now, you're doing the square root. So that rather than having to constantly, you know, rebuild and recreate these sub-VIs, you can just modify them. You can save them as different names, but one thing that you notice is it didn't change this variable name, because this variable name got its name from the sub-VI, but once we've written it in our new VI, it doesn't read the name anymore. So if we delete it, so if we delete this, and delete the wire2, and now right click, and then go to create indicator, it'll rename it to what the VI, what the sub-VI says, and not. Yeah?
What did you do?
So if you delete the, you know, just to show you how the naming things change. So you have x plus y, what does it say in your VI, in the sub-VI? Did you change the value in the sub-VI?
Yeah, I changed this.
Okay, but it's still called x plus y. Change what this is called. So if you change that name.
No, it doesn't matter.
Yeah, it's good. That's it.
I can.
It's fine. Doesn't matter. Yeah, exactly. Okay, and it's got a file save. No, just save. Don't save it as anything, just save it. There you go. So if we save it as something other than that.
I did in the past.
Yeah, so if you save it as something, it'll make a new version of it, but then your VI won't have that built in. You'll then have to replace. So right now, we have this VI you know, in here, and it's called a certain name. If I open this up and save it as Fred, you know, then this VI is being told to read sum and square, not Fred. So if I save it as something, I then have to select the VI and re-import it. If you hit save, then it'll just keep the same structure and it's keeping the same name because it's still pulling the name. It's good to hit save as if you're making changes that you know you want to have as reversible and things like that. But then what you do is so if I hit. So this isn't really saved in square, this is saved in square root. So if I want to have this as saved in square root, then I need to, you know, this guy is saved in square root. And if we want to pull in the other one, we then have to go to select VI and then put it back in. It's just a little, I mean, it's nothing major. Okay, so then we have, you know, the ability to change it. You know, on the fly, we've been running it in real time. We have input and output nodes, and this essentially is the essence of what a sub-VI does. They're small programs, and like the one from the example, thinking about it, it's going to be way more complex. That I think it will take me more than an hour to explain to you exactly how it works. I can talk through it actually rather than making you guys build it. It might be a little bit more usable that way. So I mean, we can, you know, pick some files and look at it, but this VI that does the listing, this one is building file paths. So we have a list of all of the names here. So this lists all of the names. And these are in a big array because there's a lot of them. Then when we go into the for loop like we have before, we've been incrementing the file name. So we've been indexing the files. But right now at this point, they're kind of in an arbitrary order. They're whatever order it kind of fancies naming them. There's no there's no particular order. But this is applying a pattern to it. So here we've selected only files which end in _ch00.jpg will go into this list. We can change this pattern to be whatever we want to change it to. The general one that I was using is just star.jpg, so that it can just get around having video files or text files and stuff in the same folder. It only analyzes images, it just ignores the file names. But anyway, this kind of level of thinking is like it's hard until you start looking at particular problems. So our problem is, I was going to set it as a problem, but I thought it might give you guys too much of a headache, so I decided not to. We have a list of files that are not in order. Whole lot of numbers, they're not in order. So you have to think, how can I take this list of files that are not in order and order them? Because Windows won't order them. Windows will order them the way that I showed you. Unless Windows 7 and Vista exhibit differences. They're taught how to deal with it. But lower level languages like programming codes and things aren't taught how to deal with it. So you have to think, okay, I have this list of files and I don't know how to order them. So that's kind of where this comes from. I have to give each of the files some kind of identity so that I can order them on something other than their number, because I'm already being told that it can't list them in the right order. Windows, I've already, just like in the starter video I showed you with just 4 files, if I say order them, it gives them a wacky order. And we need to put it in the order that we want. So we need the order from lowest number to highest number, which in how they're programmed also means that we need to order them into sections. So we need to separate them out by how many digits that file name is. So we need to say, okay, let's look at a file name of length 1. Okay, then order all of the files that have the length 1. Okay, and then those ones go first. And then we have, all the ones which have 2 digits. And then order those ones that have 2 digits, and so on. And that's kind of what we're doing here, is we have to write our own code to say, look, we can't let Windows order them all together because it can't do it. But what it can do is order them that are the same file length. So the same file length, it can order them correctly. So what we're doing here is assigning a secondary attribute. So rather than it just being a file name, so this is a list of file names. Rather than it just being a file name, what we're doing is we're changing this file name into a string. So it becomes a string of characters. We're then measuring how long this string is. We're saying, okay, how long the file name does this file have? We're then attaching them together. So like I was telling you in the other 2 sessions, this is called a cluster. So we can bundle different types of data together and keep them together at all times. So essentially we've got this file name, which, but we want to add an extra attribute, which is how long is this file name. Okay. So then once we've got those 2 things, we stick them in a big list. They essentially come in, you can treat how they come in as an arbitrary sequence. It can be all over the place, there's no particular order. And how they come out is an arbitrary sequence. They're all over the place, there is no particular order. But because each file name, as it's read in, we are now giving it an extra bit of data, which is how long the file is. We are now not using this order that they were inputted and outputted in as our reference. We are now using this extra character that tells us how long the file name is. So here the bundle is in this way because of a reason. So the cluster reads how long the file name is first, and then it adds the string. Okay, if these were the other way around, then this little sort list thing wouldn't work, because it would try and sort them based on the file name. We don't want them to sort them based on file name. We need to put them in a big list based on how long that string is. So how long your file name is. So we have the how long your file name is first, and then we have the where you are. So it orders them based on, like, if this is one like character long, and then 2 characters long, and 3 characters long, etc., and goes down. And then all of the ones that are of a certain length. So let's say you've got 100 of them that are all got a file length of 10. Then it will order them based on their file length first. But then, because we're feeding a cluster in, it will order them within that 10 string length. It'll then order them based on the second bit of information, which in this case is the file name. So it's ordering first based on length of file, and then it's ordering second based on what the file name is. So we're essentially saying, look, put all of them into like categories of how long the file name is first. So file names of 10 characters, 11 characters, 12 characters, 13 characters. But then within each of those brackets, they need ordering too. So then it goes, okay, what other information do I have? Well, I have the file name. So then it uses the file name to order them within that. And essentially by doing that, we're bypassing Windows' kind of numbering scheme. We're allowing them to put them in order based on file name first, and that's the crucial part. So this orders them like that, and then we take that list of ordered files, and then we separate them back out, because we don't need these arbitrary kind of tags of file length. We put them on there so we could order them correctly. Okay, because we put them on there, we have to take them back off. So these are clusters coming in. So then we open the cluster up. Now for each list, for each article in the list, we then pull out the file name from that list. So that we've done all our ordering based on our new little kind of string length that we've added to this ordering scheme. But then we have to pull that back off. So here you're putting it in, and here you're taking it off. And you're doing this loop, and then this ordering, and then this loop. Essentially, you're putting a secondary attribute on there, reordering it based on the first attribute, reordering it based on the second attribute, and then pulling that attribute back off because you don't need it. That was there for the sole purpose of creating a list. But the result is we get to do, first of all, we find out what's in the folder. We filter it based on what we say filter. And we then order them based on an ordering scheme that we know to be more sensible. You can use this type of VI all over the place, and it's very universal, meaning even if they're in the right order, you can use it anyway, because it doesn't destroy any order. It just relooks at it. I mean, if let's say you've zero padded with the 6-0 thing, then they all have the same file length. So they're all the same number, they're all the same length, so they all go into one bucket, and then they're ordering it based on the file name anyway. It's kind of assigning them a number first, and then ordering them all basically into the same bracket, and then ordering within that bracket. So it will work even when they are essentially in the right order, but it will apply this little filter thing to it. So if you just need a filter, you can use this. If you need a filter and an order, you can use this. So it's quite a universal use sub-VI. Some that you'll make won't be, some that you'll make will be. This one, however, is quite universal.
How long do you use this place?
About another minute.
Oh.
Could you create a new file with this? Like, for example, you want to use the result with another software.
Yeah. So you mean extract all of these files?
And put in a good order, for example?
You mean like rename them so that they're named correctly?
Mm-hmm.
Exactly. Yeah. I mean, what we have right now is just listing them. So file 1 is still called file 1. But what we would do is essentially, create a little, like I was showing you at first, a little zero pad thing, so that when it brings in file 1, that we name it 0001. And equally, lots of times the file numbers are, well, and depending on how they're written, they aren't always, you know, a contiguous sequence, for example. You know, maybe you've got files 1, 4, 7. You know, maybe they're incremented by a different number. Sometimes they're attached to a millisecond value instead of an actual file number. It's like what millisecond it was on when it recorded that image. You know, so it might not be a regular sequence. You know, but when we read it in, once it's ordered it, we can give it a regular sequence name. We don't have to keep the original file names. We can just make our own up. And then we can choose them, you know, we can zero pad them the right way. We can, you know, make them a more universal file name and file structure. So that we can do, you know, quite easily. And if there's a particular example, I can show you how you would do that. I mean, in this scenario, where you would do it would be here. You know, we would, you know, the first section is creating the order, adding the extra features, sorting it, and then here is when we've actually pulled out, you know, file number 1, you know, this is what we are. So instead of reading, you know, this, essentially what we would do is go to the file input output, we would then strip it. So we would strip the path off this file. Okay, and then right next to it, we would build the path. We'd pull over this path sequence, but rather than having this here, you know, we could do something as simple as, so this would be the simplest option. So we create an increment, because I don't like file name 0. It always looks weird having file name 0. So what we do is we add 1 to I, so that you start at 1 instead of starting at 0. We then feed that to make a string. So we go number to string, and then we feed string into here. Okay? Now, one issue with this right now is that it doesn't have a file extension. You know, it's just got a number. So what we would do is concatenate the string. So we go over here to the, like, kind of build the string function. And rather than wiring it straight in, you know, we wire this there, and then you can add a constant value here. You know, if you know that your files are JPEGs, you can use JPEGs. You can also strip what it is from your from the data that we're reading in. So if we go to File Input Output, go to Advanced File Functions, and then where are you? Get File Extension. What we can do is pull this path in. Okay, and then we have a little thing that's called lowercase file extension, and we want to put that into here, but we need to actually put a decimal point in there too, because right now it just has we're reading in JPEGs, so it calls the file extension JPG, but when we write the file name we need to write .jpg, so we need to put that dot back in there, but then essentially we can wire this guy straight into there. There, and then feed that into here. We don't actually need to create an indicator, but now what we're doing is we've come up with our own naming scheme for these files as they're coming out. So right now nothing's been opened, nothing's been created or destroyed. All we're doing is we're looking at file names. And what we've done using this kind of switcheroo thing is orders the file names in order, reads the file location in. So once it's got the location, it then goes, okay, I don't need your file name anymore because I'm going to put mine in there. And what we're doing is we're creating a new file name, just a simple number, based on what number in the list that file is. So if there were JPEGs, for example, you'd want to open the file and then resave it. You know, so you'd have to go to your Vision palette. You'd go to Files, you know, Read File. So you'd read the file from this list, because this is the file list. But then you'd need to write the file too. So we'd have to go to Vision. Oops. Files not out. Write file. Switch this to JPEG. Just feed that straight in. but now it's going to say, where do you want this file to go? Well, we've made our own new file name, that's where I want it to go. Stick the arrows together, you don't have to, but it makes things look better if you do. And the only thing that we need to add right now is there's no buffer in the memory for this. So we have to make a little buffer memory because we have to open the file if we want to resave it as something else. So, we just push that guy in there. And you can give this any name, it doesn't matter because it's just a temporary buffer. It's just it needs to be somewhere when it opens it. There probably is also, this then rewrites all the files. So then you could run this, and this would, if you had an arbitrary file of JPEGs, running this program now would filter them for that particular value and then rename them based on what number in the list they are. If there's probably a file rename function, I would generally stay away from it because if it screws up, in other words, your program isn't 100% perfect, you're going to screw up all your files. You're much better remaking the file and screwing up, because the worst that happens then is your output file is wrong. You did something wrong, it doesn't work. You haven't actually destroyed the files that you're using. If you have file renaming things, there's a chance that you might just destroy the file. Just like in any programming language, you can do really bad things. And Labview is exactly the same. You can corrupt a file if you do something wrong to it. So because we're not doing anything really computationally heavy, remaking an image file doesn't cost you anything. So it's much better to just remake it. So all this is it remakes the image file and then you rename it so that your original data set is never touched. And as a general rule, that's what I would do. Don't touch your original data, remake it like this, and then you're fine. Okay, so we're going to stop there, and because I got another meeting. Stop.